Hi students, good morning. In the last class, we have discussed some problems related to the binomial theorem and concepts. In this session, we are doing some another problems. Okay, let us start. See the problem. Find the numerically greatest term in the expansion of 4 plus 3x whole power 15 when x is equal to 7 by 2. Now I have to find the numerically greatest term in the given expression. Okay, see the solution. What is given expression? What is given expression? That is 4 plus 3x whole to the power of 15 whole to the power of 15. What is here? X is 7 by 2. Here the x value is given 7 by 2. When x is equal to 7 by 2, what is the numerically greatest term in this expansion? Now this expansion is converted into the standard binomial expression. So now we have to take common thing 4 from this expression. 4 plus 3x whole power 15. Now we are converted into the standard binomial expression. That is 1 plus x whole power n form. So now we are common 4 here, 4 to the power of 15 into 1 plus 3x by 4 whole to the power of 15. Now this is the expression in the standard binomial expression. So 1 plus x whole power n form. So in that form, how to find the numerically greatest term in that expansion? So first we have to find the n plus 1 mod x by 1 plus mod x. Now first we have to find this value, that is n plus 1 mod x by 1 plus mod x. What is here? N is 15, that is 15 plus 1 into modulus of x. In the place of x here, 3x by 4 by 1 plus modulus of 3x by 4. That is equal to, what is here, 15 plus 1, that is 16, into here 3 by 4 into what is here, x value is given 7 by 2. Here x value is given 7 by 2 by 1 plus 3 by 4 into 7 by 2. Now this is here that is 4 into 2, 8, 2s are 16, that is 2 into 3 into 7, 2 into 3, 6, 6 into 7, 42 into the denominator is 4 into 2, 8 will come to the numerator by here 4 into 2, 8, 8 plus 3 7s are 21, that is 42 8s are 2 8 2s are 16, 30 to 33, 336 by 29. Okay, so this is the value n plus 1 mod x by 1 plus mod x is 336 by 29. So it is divided by 29, then we are getting 11.58 something. Okay, so it is not an integer, which is not an integer. Here n plus 1 mod x by 1 plus mod x, that is 11.58, it is not integer. Then we have taken this step value, that is small m is equal to, what is the step of this value, n plus 1 mod x by 1 plus mod x. We have taken step of this value. That value is here 11.58. That is 11. What is the integer part of this one is 11. M is we have taken 11. So therefore, what is the numerically greatest term? If this value is not an integer, t m plus 1 is the numerically greatest term. Therefore, we are getting t m plus 1. T m plus 1 is the numerically greatest term in the given expression. So what is here? That is t m is 11 plus 1, that is t12 is the numerically greatest term. Okay, now we are writing the term is, what is the term? That is t12, that is t11 plus 1, that is equal to, what is here, n t r plus 1 term, that is r is here 11. So what is the given expression? 4 plus 3x whole power 15. Now we are writing NCR. So what is the general term? That is TR plus 1 is NCR. That is here we are writing the general term TR plus 1 is equal to NCR x power n minus r a to the power of r. This is the general term. Now we are writing T 11 plus 1, that is n is here 15 c r is here 11, 15 c 11. What is first term? That is 4 to the power of 15 minus 11 into, what is the second term? 3x whole power 11, that is equal to 15c 11. That can be written as 15 minus 11, that is 15c4. This 15c11 can be written as 15c4 into 4 to the power of 15 minus 11, that is 4 into here 3 to the power of 11 x power 11. What is here? X is given here 7 by 2 whole to the power of 11. Okay, so this is the numerically greatest term in the given expression 4 plus 3x whole power 15. Okay, see another problem. Prove that the series 2c0 plus 5 into c1 plus 8 into c2 and so on 3n plus 2 cn is equal to 3n plus 4 into 2 to the power of n minus 1. So this is our proving result. Now we have taken LHS. Okay, see the solution. What is here? Taken LHS. What is we have taken LHS of our proving result. What is the series given? 2 into C0 plus 5 into C1 plus 8 into C2 plus so on plus 3n plus 2 cn. This is LHS. Okay, now this value is 3n plus 4 into 2 to the power of n minus 1. Here we are observing this, these are the coefficients 2, 5, 8 and so on 3n plus 2. These are the coefficients. These are the terms in AP. So what is the common difference? 5 minus 2, that is 3, 8 minus 5, that is 3 and so on. Okay, now these are the coefficients are in GP. We are discussing the formula. What is the formula? That is A C0 plus A plus D C1, A plus 2D C2 and so on, A plus ND Cn is equal to, what is the formula? 2A plus ND, 2A plus ND into 2 to the power of n minus 1. That is we are discussing the formula. This is the formula we are discussing in the last class. Here we are observing the the coefficients of binomial coefficients C0, C1, C2 and so on Cn. These are the coefficients 2, 5, 8. These are like this A plus D, A plus 2D. These terms, these coefficients are in AP. Now we are comparing this one. Here A is to A plus D, that is 2 plus 3, that is 5, and A plus 2 into 3, 6, 6 plus 2, that is 8, and so on. So now we are comparing the LHS is this formula. We are getting what is this result 2A plus ND into 2 to the power of n minus 1, where what is the coefficients are like 2, 5, okay, 2, 5, 8, these are in AP, okay. So where 2, 5, 8, and so on, 3, n plus 2, these are in AP, okay, these terms are in AP. And what is the common difference? And small d, that is common difference is 3. Here d is equal to 3, and what is here first term, and what is here first term? That is the term, that is 2. A is equal to 2 and d is equal to 3. Now we are writing this LHS. Now we are writing the LHS. This is the series. This can be written as that is 2A plus ND into 2 to the power of n minus 1. That is here 2 into what is A here? A is 2 plus n into what is D? That is the common difference, that is 3 into 2 to the power of n minus 1. That is what is that is 2 2 into 2, that is 4, that is 4 plus 3n into 2 to the power of n minus 1. Okay, sorry, this is not 2, this is 4. 3n plus 4 into Cn. Okay, so sorry, this is okay, it is 2. Okay, now proving that result is 3n plus 4 into 2 to the power of n minus 1. Okay, so this is the series 2 into C0 plus 5 into C1 plus A8 into C2 and so on, 3n plus 2 into Cn. That series is equal to, we are obtaining here, that is equal to 3n plus 4 into 2 to the power of n minus 1. That is our proving result. This is the our given series value is 3n plus 4 into 2 to the power of n minus 1. Okay, these are the we are proving by this result. Okay, this is the important result. Using this result, we have to find the given series is 3n plus 4 into 2 to the power of n minus 1. Okay. See the problem. Prove that C0 minus 4C1 plus 7 into C2 minus 10 into C3 and so on. That value is that series is 0. If n is an even positive integer, here n is even positive integer. Now we are proving this result. See the solution. What is here given? Series is given that, what is the given series? That is C0 minus 4 C1 plus 7 C2 minus 10 C3 and so on. This is the our finding the result. So that is the LHS. That series is equal to 0, where n is an even positive integer. Now this series can be taken in sigma notation. Sigma, we are writing this is here we are getting plus minus alternatively, then we are writing minus 1 to the power of r, and the terms here 3r plus 1 cr, where r is running from 0 to infinity. Okay, So that is those are 0 to n. So minus 1 to the power of r, 3r plus 1 into cr. So that is the expression in sigma notation. If we take r is equal to 0, then minus 1 to the power of 0, that is 1. Here 3 into 0, 0 plus 1 into c naught. Then we are getting the first term. If r is equal to 1, then we are getting minus. Here 3 into 1, 3 plus 1, that is 4 c1. Okay. If r is equal to 2, then we are getting so 2 into 3, 6 plus 1, that is 7 c2. Here we are getting minus 1 whole square, that is plus. So these are the terms we are getting r is equal to 0, 1, 2, 3 and so on. Okay. So this is the notation of the given infinite series. Okay. That is equal to sigma r is equal to 0 to n r. Okay. Minus 1 to the power of r. Now we are writing this is 3 is the constant. Now we are minus 1 to the power of r into r cr. That is the first term. Next plus sigma r is equal to 0 to n minus 1 to the power of r into cr. Okay. Now we are split into two terms. Minus 1 to the power of 3r into cr, that is one term, and 3 is constant. We are writing first then minus 1 to the power of r into 1 into cr, that is the second term. Okay. Now we are writing this is 3 into, now we are writing r is equal to 0. If r is equal to 0, that is 0 into something 0. So then next r is equal to 1, we are getting minus 1 to the power of 1, that is minus 1. R is 1, that is c1. Next r is equal to 2, that is minus 1 whole square, that is plus. We are getting r is equal to 2, that is 2 into c2. So r is equal to 3, that is 3c3. We are getting like this. This is the series. Next second series is that is sigma. R is equal to 0, then we are getting c naught. R is equal to 1, then we are getting c1 plus c2 minus c3 and so on. These are the two series we are expanding. So here we are common minus here. Minus is common. Then 1 into c1 minus 2 into c2 plus 3 into c3 and so on. These are the two series. C0 minus C1 plus C2 minus C3 and so on. So we are already discussing these. This term is 0 and this term is also 0. Once again I recalling this one. Suppose we are taken 1 plus x whole power n. That is the standard binomial expression. So what is the expansion? That is C0 plus C1 x plus C2 x square and so on, cn x to the power of n. Now we are differentiation with respect to x on both sides. What is here? N into 1 plus x whole power n minus 1. Then we are getting c0 is constant, that derivative is 0. Then we are getting c1 x derivative is 1 plus 2 into c2 plus 3 into here x and this is 3 into c3 x square and so on, n into cn x to the power of n minus 1. Okay. Now like this. So put x is equal to minus 1, this will be 0. Here c1 minus 2c2 plus 3c3 and so on. So we are getting this is the result 1c1 minus 2c2, that is 1c1 minus 2c2 plus 3c3 and so on. This will be 0. And if you take directly, we are taken put x is equal to minus 1 in this equation. We are already discussing that put x is equal to minus 1 in equation 1. Then we are getting that is c0 minus c1 plus c2 minus c3 and so on. This will be 0. So these are the result already we have to done. So these are the, this value is 0 and this is value is also 0. Okay. So this is minus 3 into 0 plus that series also 0. So that will be 0 and 0. So this series is 0. That is our proving result. The series C0 minus 4C1 plus 7C2 minus 10C3 plus and so on. This value is becomes here 0. Okay. See the another problem. Prove that the series is C1 by 2 plus C3 by 4 plus C5 by 6 plus C7 by 8 and so on. That is equal to 2 to the power of n minus 1 by n plus 1. Now we are proving this result. See the solution. So what is we have taken? Let S is the given LHS. Let capital S is equal to, what is the series here? C1 by 2 plus C3 by 4 plus C5 by 6 plus C7 by 8 and so on. This is the given series. That is the given series. C1 by 2 plus C3 by 4 plus C5 by 6 C7 by 8 and so on. Now we have taken that is S. Now we are write this. What is C1 is nothing but NC1. Now we are writing the C1 is that is the notation NC1 by 2 plus NC3 by 4 plus NC5 by 6 NC7 by 8 and so on. Now we are writing the values of NC1. What is NC1? That is NCR formula. That is NC1 is N by 2. What is NC3? What is NC3? That is NCR formula. So NC3 is n into n minus 1 into n minus 2 by 3 factorial. Okay, that is NC3, that is n into n minus 1 into n minus 2 by 3 factorial. 3 factorial becomes in denominator into 4. That is the value. Okay, next what is NC5? That can be written as n into n minus 1, n minus 2, n minus 3, n minus 4 by 5 factorial into 6. So here NC5 in the numerator 5 terms, n minus 1, n minus 2, n minus 3, n minus 4 by 5 factorial. 5 factorial becomes in denominator like this and so on. This is the series. LHS is yes. Okay, S is equal to this term. These are the terms. Here we are writing the n plus 1 on both sides, multiplying n plus 1 on both sides. Here n plus 1 multiplying with n plus 1 on both sides. In LHS, n plus 1 into S is equal to here n plus 1 into n by 2, that can be 2 factorial. Next here n plus 1 into n minus 1 into n minus 2 by 3 factorial into 4, that is 4 factorial. That is 4 factorial and so on. Now we are writing like this. Here n plus 1 into n by 2 factorial. Here n plus 1, n minus 1, n minus 2. That is here numerator 4 terms, in denominator 4 factorial. These are can be written as n plus 1 C2. This n plus 1 into n by 2 factorial can be written as n plus 1 C2 plus this can be written as n plus 1 C4 and so on. Next term is n plus 1 C6. Okay, these are the terms. That is equal. Now here LHS n plus 1 into S. Okay, now we are writing LHS is n plus 1 into S is equal to here C2, C4, C6 and so on. So now we are adding the n plus 1 C0. Now we are adding n plus 1 C0 plus we are adding the remaining term as usual, n plus 1 C2, n plus 1 C4 n plus 1 C6 n plus 1 C6 and so on. Now first term we are writing n plus 1 C0, adding this one, and in last we have to subtracting the term n plus 1 C0. Now this is the terms of C0 plus C2 plus C4 and so on C6. Here n is n plus 1. We are discussing the formula, that is one, that one is okay, this is the formula we are already discussing. C0 plus C2 plus C4 plus C6 and so on. This value is 2 to the power of n minus 1. So C0 plus C2 plus C4 and so on, even suffix sum, that is C0 plus C2 plus C4 plus C6 and so on. This value is 2 to the power of n minus 1. If we are writing here C0 is nC1, C2 is nC2. Here in the place of n is n plus 1. In the place of n we are here n plus 1. So this value is becomes that is equal to, that is 2 to the power of, here n is n plus 1. 2 to the power of n minus 1. Using this formula, here in the place of n is n plus 1. We are getting here 2 to the power of n plus 1 minus 1. Minus, what is the last term? N plus 1 C0. This value is 1. N C0 is 1. That n plus 1 C0 is also 1. And this is value is 1. Then this can be written as 2 to the power of plus 1 minus 1 is cancelled. 2 to the power of n minus 1. Therefore, S is equal to 2 to the power of n minus 1 by, now this n plus 1 is moving to RHS side. Then we are getting S is equal to, then we are getting here S is equal to 2 to the power of n minus 1 by 2 to the power of n minus 1 by n plus 1. So that is our required result, that is 2 to the power of n minus 2 to the power of n minus 1 by n plus 1. So our proving result is 2 to the power of n minus 1 by n plus 1. This is S. S is the we have taken LHS of the our proving result. Okay. So what is S? C1 by 2 plus C3 by 4, C5 by 6, C7 by 8 and so on. This value is 2 to the power of n minus 1 by n plus 1. Okay. Okay. See the problem. Prove that C0 plus 3 by 2 C1 plus 9 by 3 C2 plus 27 by 4 C3 and so on. 3 to the power of n by n plus 1 Cn is equal to 4 to the power of n plus 1 minus 1 by 3 into n plus 1. That is our proving result. See the solution. See the solution. So what is we are taken LHS is we are taken S. S is equal to, let S is equal to, what is the LHS? That is C0 plus 3 by 2 C1 plus 9 by 3 C2 plus 27 by 4 C3 and so on. The term is 3 to the power of n by n plus 1 Cn. That is LHS of the our proving result. Okay, that is given that. Now this can be written as that is C0 plus here C0 can be written as nC0. Next we are writing C1 is nC1. Denominator is 2. Now this 3 can be written in last. Next here C2, that is C2 can be written as nC2 by 3. Here that is 9. 9 can be written as 3 square. That 9 by 3. Okay, 9 can be written as here 3 square. Next we are writing that is nC3 by 4 into that is 27. That is 3 cube. Okay, 3 cube and so on, plus NCN by n plus 1 3 to the power of n. Now we are writing this one. Okay, that is LHS is S. Here NC naught, NC1 by, okay, now we are writing. So what is NC naught value is 1. Now we are writing the binomial coefficient values. NC naught is 1 plus here NC1 is n by 2 into 3. Here NC2 n into n minus 1 by 2 factorial into 3 into 3 square. Here 3 square. What is NC3? n into n minus 1 into n minus 2 by 3 factorial into here 4. Okay, into 3 cube plus so on. What is here? NCn is 1 by n plus 1, 3 to the power of n. Now that is equal to, now here in denominator this is 2, that is can be written as 2 factorial. So here 2 factorial into 3, that can be written as 3 factorial. So if you 3 factorial in numerator 3 terms. So here 2 factorial in numerators we are getting 2 terms, and this will be okay 3 square. Okay, so 2 factorial, the power of 3 is the second term of the binomial expression is power is 2. Now we are writing multiplying with both sides we required 3 and also n plus 1. Here 3 into n plus 1, we are multiplying with both sides with 3 into n plus 1. In each term RHS. In LHS 3 into n plus 1. Here multiplying each term by 3 into n plus 1. Now this is 3 into n plus 1. That is 3 into n plus 1. Okay. Plus here what is here n plus 1 into n. Now we are multiplying with n plus 1 into 3. So this 3 into 3, that is 3 square. By in denominator 2 factorial. In denominator 2 factorial. Here also n plus 1 into n minus 1. By here 3 multiplying with 3, that will becomes 3 cube. By denominator 3 factorial. So now we are writing like this. The last term is here multiplying with 3, that is here n plus 1 by n plus 1. Here n plus 1 into 3. So 3 into 3 power n, that is 3 to the power of n plus 1. Okay, this can be written as here this n plus 1 can be written as here n plus 1 c1 into 3. Okay, n plus 1 c1, that is nothing but n plus 1 c1 is n plus 1, n c1 is nothing but n. So here also n plus 1 c1 is n plus 1 c1 is n plus 1. Here writing this here 3. This can be written as n plus 1 into c2, n plus 1 c2. That is here n plus 1 into n by 2 factorial, that is n plus 1 c2. So here 3 square, that is 3 square. This can be written as n plus 1 c3 into 3 cube and so on. The last term is n plus 1 by n plus 1, that is 1. That is nothing but n plus 1 c n plus 1 into 3 to the power of n plus 1. Okay, now we are writing in the first term is n plus 1 c naught. Here there is no c naught term. Now we are writing n plus 1 c naught plus n plus 1 c1 into 3. Okay, plus n plus 1 c2 into 3 square and so on. The last term is n plus 1 c n plus 1 3 to the power of n plus 1. Now this is the terms. Here we are adding this n plus 1 c naught. Now in the last we are subtracting, the term is n plus 1 c naught. Okay, so this is the expansion now like this. So n plus 1 c naught, n plus 1 c1 into 3, n plus 1 c2 into 3 square and so on. So what is the binomial expansion? Here the binomial expansion 1 plus x whole power n, that is equal to, that is nc naught plus nc1 x plus nc2 x square and so on ncn x to the power of n. So this is the in this form. Okay, so RHS is in this form: NC naught NC1x NC2x square and so on, NCn x power n. So in the place of n here n plus 1, and in the place of x is we are getting here 3. Okay, so where n in the place of n is n plus 1, in the place of x is 3. Now this can be written as therefore this can be written as 3 into n plus 1 into s is equal to, this series can be written as what is this series 1 plus x. What is x? In the place of x is 3 to the power of n. What is here n? N plus 1. N plus 1 minus, in the last term n plus 1 c naught, that is n c naught is 1, n plus 1 c naught is also 1. So this is 1. Okay, now that is equal to 4 to the power of n plus 1 minus 1. Therefore this is therefore s is equal to now 3 into n plus 1 moving to RHS side, then we are getting here 4 to the power of n plus 1 minus 1 by 3 into n plus 1. So this is the result. Here s is equal to, we are obtaining 4 to the power of n plus 1 minus 1 by 3 into n plus 1. That is our proving result is 4 to the power of n plus 1 minus 1 by 3 into n plus 1. That is the given in series is becomes here 4 to the power of n plus 1 minus 1 by 3 into n plus 1. Next problem. Prove that c naught plus 2 into c1 plus 4 into c2 plus 8 into c3 and so on plus 2 into cn is equal to 3 to the power of n. Now we are proving this result. See the solution. We are taken LHS. LHS is equal to, what is given, c naught plus 2 into c1 plus 4 into c2 plus 8 into c3 and so on plus 2 into cn as 2 into 2 to the power of n into, sorry, that is 2 to the power of n into cn. That is our given LHS. Okay, now we have to prove that this LHS value is 3 to the power of n. Okay, now we are writing this one is what is c naught? C naught is denoted by nc naught. So here c1 is nothing but nc1. This 2 can be written as here. Next, what is c2? That is nc2. This 4 can be written as 2 square. Okay. Next, this c3 is written as nc3. That 8 can be written as 2 cube, like this and so on. Here cn, that is ncn into 2 to the power of n. So this is the expansion is here nc naught plus nc1 into x, nc2 x square, nc3 x cube and so on, ncn x to the power of n. So this is the standard binomial expansion. What is the standard binomial expansion? 1 plus x whole power n. What is this expansion is nc naught plus nc1 into x plus nc2 into x square, like this, ncn x to the power of n. So this is the binomial expansion. So we are observing here nc naught plus nc1 in the place of x here 2. Here nc2, here 2 square. In the place of x is here 2 square, 3 square, like this, 2 to the power of n. Now this RHS is comparing this one where in the place of x is 2. Then this LHS, now we are writing LHS of the given expression, that is this series can be written in the place of 1 plus x. In the place of x is here 2, that is 1 plus 2. In the place of x we are writing 2 to the power of n, to the power of n. That is 1 plus 2, that is 3 to the power of n. That is our proving result. that is RHS. Okay, so LHS is equal to RHS. It is a simple theorem. See the next problem. Find the sum of the series here. 15C1 by 15C0 plus 2 into 15C2 by 15C1 plus 3 into 15C3 by 15C2 and so on. 15 into 15C15 by 15C14. Now we have to find this value. See the solution. So we have taken given series is, that is 15C1 by 15C0 plus 2 into 15C2 by 15C1 plus 3 into 15C3 by 15C2 and so on, plus 15 into 15C15 by 15C14. So this is our given series. Now we are writing this is equal to, here this is NCR by NCR minus 1. So this is the formula we are already discussed. This formula NCR by NCR minus 1 is equal to N minus R plus 1 by R. Using this formula, here these are the terms in this form, 15C1 by 15C0. That is, here N is 15, here R is 1 and R minus 1 is 0. Okay. Now using this formula we are writing here NCR by NCR minus 1, that is N minus R plus 1 by R. N minus R plus 1 by R. We are writing this one, that is 15 N minus R. R is 1 plus 1 by R plus 2 into, here N is 15, N minus R. R is 2 plus 1 by R. R is 2. Okay. Now we are, every term is writing in this form. So that is 15 minus 3 plus 1 by, that is R. R is 3. Here R is 3, R minus 1 is 2 and so on. 15 into 15C, that is here also NCR by NCR minus 1. 15 minus N minus R plus 1 by R. R is here 15. Okay. Now each term we are writing using this formula NCR by NCR minus 1, that is N minus R plus 1 by R. Now we are writing here, that is 15 minus 1 plus 1 will be cancelled. This is 15. Here 2 will be cancelled. That is here 16 minus 2, that is 14. Next here 3 and 3 will be cancelled. That is 16 minus 3, that is 13. Like this. The last one is here 15 cancel, here minus 15 plus 15 cancel. That is 15 plus 14 plus 13 and so on 1. This is the sum of n natural numbers, 15 natural numbers. So what is the sigma n formula? It is sigma n, that is n into n plus 1 by 2. Sum of n natural numbers. Here n is 15. So that is here n is 15. N into n plus 1, that is 15 plus 1 by 2. N into n plus 1 by 2, that is equal to 15 into, that is what is here 15 into plus 1, 16 by 2. 8. 8 5 are 40. 8 plus 2 12, 120. So the value of this given series value is 120. Okay.